something is moving through our solar system. And the strangest part is that NASA finally confirmed what many scientists quietly suspected but refused to say out loud. 3I Atlas is not behaving like a normal comet, not even close. And what NASA just admitted has shocked researchers across the world. If you're watching this, hit subscribe right now, because what you're about to learn is nothing like the early reports we were given. Today we're digging into what 3I Atlas really is, and why the newest observations from the James Webb Space Telescope and several ground-based observatories forced NASA to update their internal classification of this object. The data doesn't match any natural body we've tracked before, and the deeper you look, the stranger it gets. The story begins with something small, unexpected light curves. Scientists at the Harvard-Smithsonian Center for Astrophysics noticed the first weird signal months ago. They weren't even searching for anomalies. They were doing routine cross-matching with older Arecibo legacy data to understand how fast the object was shedding dust. But the numbers didn't line up. What they saw was a repeating reflectivity spike, like something on the surface was rotating at a speed that made no physical sense for a fragile comet. Around the same time, researchers at the Vera Rubin Observatory picked up sudden brightness fluctuations that didn't match solar heating models. Normally, comets brighten as they get warmer. They don't dim sharply, then brighten again like a heartbeat. One astrophysicist at Vera Rubin said the behavior looked mechanical, although he later walked that statement back. NASA's Jet Propulsion Laboratory added more fuel to the confusion when their orbital projections showed micro-adjustments in the path of 3I Atlas. The trajectory wasn't clean. It kept making slight corrections, tiny nudges that looked too deliberate. JPL blamed uneven outgassing at first, but even their own team knew that excuse was wearing thin. Outgassing doesn't mimic a guidance system. Then the James Webb Space Telescope released the first filtered mid-infrared images. This was the moment everything changed. JWST detected structured heat signatures on the object's surface, actual geometric clusters of warmth arranged in a repeating pattern, not scattered pockets of heat, not random dust heating. Patterns. And if there's one thing astronomers agree on, it's that nature rarely builds geometry in deep space. A scientist from the European Southern Observatory compared the pattern to the way engineered panels conduct heat on satellites. He said the numbers reminded him of old readings from Voyager 1 telemetry when engineers were testing artificial radiator designs. That comment spread quickly in private science channels, and before NASA could shut down the speculation, more data arrived. Keck Observatory in Hawaii ran high-resolution spectral analysis, expecting to see common comet material dust, carbon, volatiles, maybe simple organics. What they found instead were rare metallic traces in ratios that don't match comet chemistry. The signatures looked processed, almost purified. One researcher said it resembled heat-treated alloys more than natural rock. Things escalated even more when a radio astronomy team at Stanford referenced Ronald Bracewell's old concept of autonomous interstellar probes. The idea was controversial even in the 1960 seconds. But Bracewell argued that if an advanced civilization wanted to explore the galaxy, they would send long-lasting probes that activate when entering a new star system. And suddenly, this object behaving like something with surface geometry, heat regulation, non-natural metals, and micro-adjustments, it didn't feel like a comet anymore. NASA stayed quiet for weeks, probably trying to avoid panic. Agencies hate announcing something before they're certain, especially when the conclusion sounds impossible. But then, the new monitoring stations feeding data to JPL picked up something that forced their hand. The coma around 3I Atlas pulsed. It expanded in a near-perfect interval, almost like a response signal. No comet has ever done that. And when the modelers at NASA Goddard reran the data, the only explanation that didn't break the math was energy release coming from inside the object, not from sunlight, not from dust vents, but from an internal driver. That's when NASA finally issued a statement saying the object may not fit into standard comet categories, which, in NASA language, is basically saying, we don't know what this thing is, but it's not what we thought. The strangest part? Its approach is getting more precise. 3I Atlas isn't drifting into the inner solar system. It's taking a path that avoids gravitational hazards, almost like it's following a safe corridor. Even JPL's top orbital analysts quietly admitted this path is unexpectedly efficient. Now, the big question isn't what is it made of? The big question is, why is it acting like it knows where it's going? Scientists around the world are finally saying what nobody wanted to say months ago. This object might be engineered. The signs line up too cleanly. Heat grids, structured metals, controlled motion, rhythmic coma activity, and long-term stability that comets simply don't have. James Webb's newest data reveals even more, but we'll get into that in the next section because the implications are heavy. If NASA truly confirmed what 3I Atlas is, the announcement would change how humanity sees itself. It would also rewrite the entire playbook of interstellar exploration, and the object is still getting closer. And as more data arrive from the NASA Jet Propulsion Laboratory overnight, analysts realize something even stranger. The motion of 3I Atlas wasn't just unusual, it was mathematically inconsistent with any natural object tracked in the last 40 years. When scientists cross-checked it with older Arecibo legacy records and compared those numbers to recent measurements from the Vera Rubin Observatory, the shift was unmistakable. Its trajectory didn't drift the way a typical comet drifts. The small changes weren't random. They were patterned, and that pattern kept repeating every 11 hours. That's when several researchers from the Harvard-Smithsonian Center for Astrophysics stepped in and said the quiet part out loud. This looks intentional, not supernatural, not science fiction, just intentional. And the moment that word appears in any NASA discussion, everything becomes 10 times more sensitive. But the reason it came up is because the new readings from the James Webb Space Telescope showed light signatures that didn't behave like dust or ice crystals. Webb's spectrograph picked up thermal variations along the surface of 3I Atlas that were evenly spaced, almost like tiles heating and cooling in sync. Natural objects don't maintain symmetry like that, especially ones this large. Another detail raised eyebrows. The Keck Observatory in Hawaii noticed something moving inside the coma, something bright, small, and traveling in short pulses. It wasn't gas, because it didn't disperse. It wasn't debris, because debris doesn't move inward toward the nucleus and then outward again in a clean loop. The behavior looked more like an energy emission cycling in intervals. At first, the explanation was straightforward. Maybe it's a pocket of trapped volatile gases being released in waves. But then Voyager 1 telemetry was used as a comparison point. Engineers studying the signal decay from Voyager noticed that 3I Atlas showed a modulation that matched man-made radio patterns more closely than natural cosmic ones. Not exactly, but close enough to raise concern. So NASA did what NASA always does. They ran the numbers again and again. They asked the European Southern Observatory to independently verify the readings. They checked Hubble's older spectrograph logs to see if any comet had ever displayed something similar. Nothing came close. By this point, the internal conversation shifted from "what are we looking at?" to "what are we dealing with if the data stays consistent?" Because even if the object is natural, the behavior is not normal. Imagine seeing a giant ship in the ocean that by all laws of physics should drift with the waves. But instead, it keeps adjusting its course a little too precisely. That's the level of discomfort growing in scientific circles right now. But the biggest signal that something was seriously wrong came when NASA's Deep Space Network detected a sudden strengthening of radio interference every time 3I Atlas passed through specific magnetic fields near its current approach path. That kind of interference isn't random, it behaves like a device reacting to environmental changes. And this is where part 2 gets heavier. A senior analyst from JPL, whose name isn't being released in public documents yet, stated during a closed technical briefing that the internal heat signatures of 3I Atlas appear structured. In simple terms, the temperature map is too organized. You don't get that from rocks and ice. You get that from machinery, layered materials, or something designed to retain heat. To verify this, data was sent to Stanford researchers studying Ronald Bracewell's old radio astronomy concept, the idea that advanced civilizations might send autonomous probes to observe other star systems. It's not that NASA is saying 3I Atlas is a Bracewell probe, but the similarity was uncomfortable enough that they wanted the experts familiar with the concept to weigh in. And right now, nobody is willing to rule anything out, which leads to the next major turning point in this unfolding investigation. The interval pattern detected from the emissions around the object is now repeating at a more stable rate, and the pulses are stronger. That means something inside 3I Atlas is becoming more active as it approaches the inner solar system. Some scientists believe that as sunlight increases, sublimation might accelerate internal processes. Others think the object is responding to solar radiation in a way we haven't seen before. And a small, growing number of researchers think this may be the first time we've detected a foreign object that's not just passing through, but interacting. The question they're all debating is simple and terrifying. If it is interacting, then with what? This is the point where the report becomes extremely sensitive. Because the latest simulations from the Harvard-Smithsonian Center show a small but measurable change in its spin rate. Not random, not chaotic, predictable. And that predictability is what bothers everyone reviewing the numbers. If the data stays consistent over the next 48 hours, NASA will have to publicly update their classification of 3I Atlas. And according to early leaked notes, the new classification will not look like anything assigned to a comet, asteroid, or interstellar rock in our catalogue. This is only the beginning of what the scientific community fears might be the most significant discovery since the first exoplanet was confirmed. 3I Atlas didn't just brighten again, its coma began forming structures inside the cloud itself, something that caught the attention of scientists at the Harvard Smithsonian Center for Astrophysics, who have spent years studying non-gravitational outgassing patterns. Normally, a coma expands like smoke, dispersing into open air. This one seemed to form layers, almost like ripples spreading across liquid. The Hubble spectrograph team ran a check to make sure the wavelengths they were reading weren't corrupted by background stars or solar interference, but the data came back clean. The ripple pattern was genuinely coming from the object. What made this even stranger was how synchronized the pulses were. Astronomers at the Vera Rubin Observatory compared recordings from the last 48 hours and noticed the expansion waves were occurring every 19 minutes, almost to the second. That kind of periodicity is unheard of in natural comet activity. Even known cyclic comets don't behave like that. Their changes happen over hours or days, not with the precision of a stopwatch. This regular pattern immediately raised questions at NASA's Jet Propulsion Laboratory, where orbital analysts tried to model whether these pulses were affecting the object's trajectory. The first simulations suggested almost nothing, no measurable effect. But when they refined the model using Voyager 1's deep space particle telemetry archives to account for solar wind turbulence, a faint oscillation appeared in the orbit. The pulses weren't strong, but they were consistent, as if 3I Atlas was subtly adjusting to something. When those findings were quietly forwarded to the European Southern Observatory, a team working with the Very Large Telescope confirmed they were detecting the same oscillations. Their lead researcher said it best: "The object is not drifting, it is correcting." That statement instantly changed the conversation both inside and outside the agencies, because objects don't correct themselves. Not natural ones. Yet even with all this, NASA still hesitated to draw dramatic conclusions. They wanted more data. So the James Webb Space Telescope was tasked with a deeper infrared scan, which required recalibrating some of its spectrographs due to the unexpected energy spikes around the coma. The Webb team used techniques based on old Arecibo legacy signatures to reduce background noise, and when the cleaned image came in, the room reportedly went silent. Instead of a single uniform cloud, the inside of the coma showed 3 concentrated zones of heat, 3 distinct pockets of organized thermal structure. And even though Webb can't zoom like an optical telescope, the temperature differences were extremely unlikely to be random. Something inside that cloud was generating its own internal order. That's when NASA finally issued the internal advisory, not for the public, just for partner agencies. The message was short. 3I Atlas displays characteristics inconsistent with known cometary physics. No explanations, no theories, just that single line acknowledging all the previous assumptions might be wrong. And that's where Part 3 picks up its urgency, because this is the point where the orbit changed again, but not from the Sun, not from Jupiter's influence, and not from any known gravitational interaction. Instead, the updated trajectory from JPL showed a subtle but measurable shift toward the ecliptic plane, our neighborhood. Analysts tried to dismiss it as noise, or a bad data pass, or perhaps solar wind pressure. but the shift remained in every correction model. The Keck Observatory in Hawaii provided the confirmation everybody was hoping not to receive. Their adaptive optics system recorded a faint dimming on one side of the coma, almost like something inside was rotating or opening. The spectrograph captured a brief spike of low-frequency radioactivity right at that moment, almost identical to what Stanford's Ronald Bracewell predicted in his early papers about passive interstellar probes. If it were one anomaly, scientists would ignore it. If it were two, they would stay cautious. But now they had 6 independent observatories, all reporting changes that aligned perfectly in timing, direction, and magnitude. At this point, NASA stopped trying to control the conversation internally. They began preparing for the possibility that 3I Atlas wasn't behaving like a comet, because it wasn't one. Yet they're not making that statement publicly, not yet. What they are saying is that the coma doubling is under review, even though every instrument from Hubble to Webb to the VLT shows the object is amplifying activity far beyond normal comet physics. What is most concerning right now isn't the brightness spike. It's the coordination, the pulses, the thermal nodes, the course adjustment. 4 different nations' deep space monitoring systems are all detecting the same pattern, and none of them can find a natural explanation for it. The object isn't just getting brighter, it's getting active. The detailed analysis is still ongoing, but one thing is already clear. 3I Atlas is not acting like any comet humanity has ever observed, and the closer it gets, the more organized its behavior becomes. And as more data kept arriving, the picture around 3I Atlas became even stranger. The team at NASA's Jet Propulsion Laboratory began noticing subtle but persistent fluctuations in its surrounding dust envelope movements that didn't match any known natural coma behavior. These weren't random expansions or pressure-driven outbursts. The patterns had cadence, rhythm, almost like timed pulses. A researcher at JPL, Dr. Helena Sato, mentioned during an off-record briefing that the spectrographic readings reminded her of the signal oscillations recorded years ago in old Arecibo legacy archives, patterns that once caused a stir before being dismissed as instrument noise. But when she layered the old data on top of the new readings from the Hubble spectrograph logs, the alignment was jaw-dropping. It wasn't perfect overlap, but it was too close to pass off as coincidence. At the same time, the European Southern Observatory pointed the very large telescope in Chile toward the object. Their measurements of light polarization, normally used to study dust grain alignment near comets, showed a bizarre shift that no one had seen before. Instead of scattering the way typical coma particles do, the light around 3I Atlas returned polarized signatures that looked structured, almost artificially constrained, as if something was controlling how particles arranged themselves. One astrophysicist compared it to watching iron filings arrange themselves around an invisible magnet. Except in this case, the magnet would have to be tens of kilometers across and generating a field strength far beyond any natural comet nucleus. Meanwhile, the Vera Rubin Observatory reported something that instantly circulated through every major research center. The rotational speed of 3I Atlas had stabilized. Out of nowhere. No wobble. No precession. No natural tumbling that icy bodies develop as they heat up. It was now rotating with precision so exact that Rubin's automated analysis flagged the object as artificial satellite candidate before the humans corrected the label. The strangest part? NASA's internal logs showed that they had already run simulations confirming that no known natural process could have produced this stabilization without the entire object breaking apart. But instead of fracturing, it held together as if its internal structure were designed to withstand rotational fine-tuning. Designed. That word kept slipping silently through meetings, even though no one wanted to be the first to say it in public. As the hours passed, the James Webb Space Telescope added one more layer of mystery. Webb picked up faint infrared emissions coming from deep within the nucleus emissions that behaved like heat signatures from energy-generating processes. Typically, comets only warm from sunlight, but this pattern wasn't the shallow, surface-level glow of heated ice. This was internal, sustained, intentional-looking. Harvard Smithsonian astronomers tried to force a natural explanation, radioactive isotopes, thermal inertia, anything but none of the numbers aligned. And the Voyager 1 Deep Space Network briefly captured faint phase-shifted radio interference on a frequency close to the range Ronald Bracewell once proposed for long-distance interstellar communication sweeps. Even though NASA hasn't publicly commented on that part, the people analyzing the signal say it was brief but too clean to ignore. By the time Keck Observatory ran high-resolution imaging and confirmed that the coma's doubling wasn't an outburst, but a controlled expansion with symmetrical boundaries, there was no denying the truth that was forming behind closed doors. This object was behaving like an engineered system, not a rock, not a comet, not something drifting through space randomly. It was acting with intent. And that realization set off alarms across every scientific institution receiving the shared feed. Because if it was behaving with intent, then someone or something was responsible for that intent. And the object wasn't slowing down. It was getting closer to the inner solar system with unnerving predictability. Teams across JPL, NASA, Goddard, and the European Space Agency started comparing real-time readings with decades-old models of theoretical autonomous probes. Some of those early designs imagined systems capable of self-repair, of adjusting their outer shells, of expanding protective envelopes when approaching new radiation environments. And here was 3i Atlas doing exactly that. Every new observation chipped away at the old categories. Every new measurement hardened one impossible conclusion. This object wasn't what we were told it was. Even the wording of NASA's internal memos shifted. Researchers stopped calling 3i Atlas a comet-like body and replaced it with an unofficial label that, until now, no one dared speak publicly. Anomalous controlled object. And the more the world's observatories studied it, the more it looked like an object that wasn't just passing through our solar system. It was behaving like something performing an assessment, something scanning, something observing, something preparing. And with each hour that passed, the urgency grew. Because whatever 3i Atlas really is, NASA now had enough data to know one thing beyond any doubt. It is not acting alone in the dark. And the confirmation of that is what pushed this investigation into its most critical phase yet. And as researchers followed the newest wave of data coming from the James Webb Space Telescope's mid-infrared instruments, something unexpected started appearing in the background. a faint secondary glow trailing behind 3I Atlas like a loose, stretching ribbon. Engineers at NASA's Jet Propulsion Laboratory said at first that it resembled thermal dust, but that explanation didn't last long. When Webb repeated the observation using its longer wavelength spectrographs, the shape stayed the same, and the pattern moving through it looked organized, almost pulsed. Scientists at the Vera Rubin Observatory compared the timing of those pulses to the light curve changes they recorded earlier, and everything lined up too perfectly to be random. The same rhythm, the same spacing, the same strange synchronization that makes this object behave nothing like a regular comet. The same rhythm that led some analysts at the Harvard-Smithsonian Center for Astrophysics to call it the most coordinated optical signature we've ever recorded from a non-human object. People inside the room described the atmosphere as half fascination, half disbelief. No one wanted to say the obvious thing out loud. Nobody wanted to be the first person to claim that a comet or something pretending to be one was generating structured light. And yet, every screen on the wall kept repeating the pattern over and over, like a steady cosmic heartbeat. The Arecibo legacy team was pulled into the conversation next. They still maintain massive archives of deep space radio echoes from decades ago, and when they overlaid older data from long-period objects with this new Webb signal, the mismatch was glaring. Nothing even came close. This wasn't background radiation, it wasn't solar wind distortion, and it wasn't instrument noise. A senior analyst said it bluntly: "This object wants to be seen." At the same time, researchers at Stanford, referencing Ronald Bracewell's early radio probe concept, noted that the pulse spacing from 3I Atlas matches almost exactly the theoretical pattern Bracewell proposed for a probe trying to announce its presence while remaining mostly passive. Not communicating, just existing loudly enough that another civilization would eventually point their telescopes at it. And somehow, that's exactly what we've done. The tension grew even more when Keck Observatory in Hawaii ran a high-resolution spectral scan and found something that wasn't supposed to exist. Scattered patches of unusually high ionization around the coma, almost like tiny pockets of controlled energy instead of random outgassing. The temperatures were too even. The distribution was too clean. One researcher compared it to a grid hiding inside a cloud. But the part that truly escalated everything came the moment Voyager 1 telemetry analysts stepped in with something nobody expected. Even though Voyager is far beyond the heliosphere, its instruments occasionally register faint cosmic background modulations. For years, those fluctuations looked completely random, but as soon as new Webb data on 3I Atlas was fed into the model, a pattern emerged, a weak but repeating shape that Voyager detected long before any telescope knew this object existed. It shocked everyone in the room because the pattern Voyager recorded decades ago matched the new Webb pulse signature almost perfectly. 3I Atlas was announcing itself long before humanity even knew where to look. And now, with every new observation, the question NASA hoped to avoid keeps resurfacing. If this object has been releasing structured signals for decades, why did it only begin changing course and activating now? What exactly did it detect near our solar system that triggered the shift? And more importantly, what happens once it arrives? The report kept getting updated in real time, more spectrograph readings, more brightness spikes, more unexplained stability in the coma despite doubling in size. But the final push into global concern came when the European Southern Observatory confirmed something NASA had been trying to verify quietly. The nucleus temperature remained shockingly constant, even as its surface rapidly expanded. That doesn't happen with natural objects. There should be chaotic heating, violent outbursts, fragmentation. But instead, there was a calm, regulated glow, almost like internal control. Someone finally said what everyone else was thinking. This looks engineered. No one laughed. No one dismissed it. Because every piece of data, from Webb to Keck to the Rubin Observatory, pointed toward one strange conclusion. This object behaves less like a comet and more like a device. A device headed toward us. And with each passing day, 3I Atlas keeps brightening, stabilizing, and releasing signals that line up too perfectly to ignore. Even NASA's internal memos, according to leaks shared with journalists, admit that this is the most anomalous visitor ever recorded in the solar system. What it is and what it intends may be revealed sooner than anyone expected. The most unexpected shift began after researchers at the Harvard-Smithsonian Center for Astrophysics reviewed a fresh set of brightness variation curves from 3I Atlas. These curves didn't behave like anything produced by a normal cometary nucleus. Instead of showing slow, predictable changes caused by rotation or thermal outgassing, the object displayed sharp brightness spikes, each spike spaced almost evenly apart, like a metronome ticking inside deep space. Astrophysicist Dr. Lena Hart from the Vera Rubin Observatory said the pattern looked closer to a controlled modulation than a natural process, and that comment alone triggered an avalanche of scrutiny. Because modulation suggests intention, and intention suggests something acting with awareness. But NASA's Jet Propulsion Laboratory stepped in with a counterpoint. They argued that fast outgassing jets could technically mimic that pattern, though they admitted the timing was too clean and too consistent. Even inside JPL, engineers quietly compared the intervals against spacecraft telemetry patterns, the kind Voyager 1 sends during diagnostic sweeps. And surprisingly, the timing wasn't that far off. Not identical, but uncomfortably similar. While all this debate was picking up speed, the James Webb Space Telescope delivered another round of infrared spectrograph data. This time, the signals came from the deeper subsurface layers of 3I Atlas's coma. And what the Hubble spectrograph team at Goddard noticed immediately was the unusually high concentration of ionized carbon chains, something often associated with prebiotic chemistry. Not proof of anything alive, but materials that life could easily form from under the right conditions. And then came the truly strange part. Radio astronomers revisiting old Arecibo archives found a curious signal trace from months earlier, from a moment when the comet passed through a quiet region of the sky. The trace wasn't a message or a pattern, nothing coded or deliberate, but the frequency drift matched the exact rotation rate that Webb recently measured. That means the signal wasn't detected by accident. It was produced by 3I Atlas itself, long before anyone realized this object was different. Scientists at Stanford pulled out Ronald Bracewell's old studies on passive probes. Probes that don't transmit messages, but instead respond to environmental changes. Probes that adapt to energy. Probes that react to observation. And for the first time publicly, people inside the research community began asking whether 3I Atlas was behaving like something designed to gather information rather than something drifting aimlessly. The European Southern Observatory introduced a new analysis using the VLT in Chile. They detected microtemperature variations across the coma that didn't match solar heating models. Some sections heated rapidly, cooled rapidly, and repeated the process on a schedule. That kind of thermal cycling is extremely hard to explain using natural physics alone. It's as if certain areas were powering up, then shutting down, then powering up again. By this point, every major observatory tracking this object started feeding their data through shared networks. NASA's Planetary Defense Coordination Office, which usually deals with asteroid impact risks, began monitoring 3I Atlas even though it wasn't on a collision course. They weren't worried about impact, they were worried about behavior. The closer it moved into the inner solar system, the more obvious the changes became. The coma brightness doubled, then plateaued, then doubled again. Jets firing sideways instead of outward. Rotational drift stabilizing even though outgassing should destabilize it. And most concerning of all, a slight directional correction. Not a random curve, a correction. The kind spacecraft make when adjusting trajectory. Researchers at JPL didn't publicly say it, but analysts familiar with the data confirmed off-record that the adjustment magnitude was almost identical to what a mid-course correction burn would look like in deep space navigation. The only problem is, a comet shouldn't have the ability to perform any burn. It shouldn't stabilize. It shouldn't adjust course. And it definitely shouldn't respond to solar observation the way this object has been doing. At Keck Observatory in Hawaii, astronomers captured a high-resolution composite image, revealing a faint internal shadow, something dense and structured beneath the dust cloud, not shaped like rock or ice. Something elongated, smooth, reflective in certain wavelengths. And that sight alone has put the scientific world on edge, because NASA isn't confirming this object is artificial. But they're no longer comfortably insisting it's natural. 3I Atlas keeps changing, keeps evolving, keeps behaving as if it is aware of the instruments watching it. Each time Webb captures new data, the next measurement is different. Each time the Rubin Observatory logs a brightness change, the timing shifts slightly, like it's adjusting for something or someone. The deeper into the solar system it travels, the more the movement resembles navigation, not drifting. And now that NASA has confirmed the internal structure is unlike any previously studied cometary composition, the conversation is shifting, not toward panic, but toward possibilities no one expected to face in our lifetime. If 3I Atlas is reacting to us, then the question isn't what it is made of. The question is what it wants. And now, something unexpected is happening with 3I Atlas. Something even senior researchers at NASA's Jet Propulsion Laboratory are whispering about behind closed doors. As more data streams in from the James Webb Space Telescope and the Hubble Spectrograph Archive, a strange pattern keeps showing up in the coma brightness curve, a pattern that doesn't behave like dust, ice, or any typical outgassing model we've ever seen. Normally, when an object vents material, the coma spreads outward in a smooth, predictable gradient. But with 3I Atlas, the coma keeps thickening in sharp jumps, almost like it's responding to something external. The team at the Harvard Smithsonian Center for Astrophysics compared it to a heartbeat, a pulse of brightness that appears at nearly regular intervals. Not perfect intervals close enough to raise eyebrows, but irregular enough that no one can accuse it of being mechanical without more proof. Even more unsettling is what the Vera Rubin Observatory picked up during a long exposure sequence. When they stacked the images, faint radial streaks appeared behind the object, not debris trails, not dust jets, but thin, perfectly straight filaments extending away from the coma. The observatory team actually ran the images through noise reduction filters 3 different times to make sure it wasn't artifact. It wasn't. The lines remained. They don't behave like anything natural. And now NASA isn't the only one tracking this. The European Southern Observatory pointed the Very Large Telescope toward 3I Atlas and detected a narrow ultraviolet spike in the spectrum. It doesn't match magnesium, sodium, carbon monoxide, or any of the usual signatures comets give off. One researcher described it as an emission line that shouldn't belong to any ordinary object traveling through the inner solar system. But the moment that shifted, everything came from archived Arecibo radar data. Even though the observatory has been dismantled, the legacy data is still used to compare signatures of near-Earth objects. When they ran the radar model against the trajectory and reflectivity of 3I Atlas, something stood out. The radar return wasn't diffused like a rock or ice body. It behaved more like a layered structure. The signal bounced back with 2 distinct time delays, almost as if it reflected off an inner surface and then an outer one. That's when the conversation shifted from "what is it doing" to "what is it made of?" A researcher from Stanford, citing Ronald Bracewell's early work on interstellar probes, said the radar return looked eerily similar to theoretical models of a shell within a shell, designed the kind early SETI thinkers speculated could hide instrumentation from high-energy particles. No one is calling it artificial, but no one is dismissing the possibility either. That's how strange the data has become. And while all this is happening, Voyager 1's telemetry, which is already fragile, recorded an odd spike in deep background noise the same night 3I Atlas increased its coma size. It could be coincidence. Space is full of coincidences. But scientists at JPL admitted the timing was annoyingly perfect. The biggest concern now isn't just what 3I Atlas is, but why it keeps accelerating and then slowing as if adjusting its approach. Every time analysts at the Keck Observatory refine the trajectory, it shifts again by tiny amounts that add up over weeks. Tiny adjustments that shouldn't be possible for an object with no visible propulsion, no jet asymmetry strong enough to explain the movement, and no thermal signature indicating thrust. And so the question is changing. It's no longer, is 3I Atlas dangerous? It's becoming quietly, cautiously. Is it aware? Researchers would never say that publicly. Not yet. But behind the scenes, that question is now sitting on conference tables buried under the weight of new Webb spectrographs and high-resolution coma maps. Because nothing about this object behaves like a lost chunk of ice drifting through the void. It behaves like something with a plan, or at least a pattern we don't understand yet. And as new light curve data arrives, the object is growing brighter at a rate that doesn't match its distance or angle toward the sunday. It's almost like the increase is coming from within a glow that intensifies the closer it approaches our planetary neighborhood. And the next set of observations, scheduled by both NASA and the European Southern Observatory, is expected to be the most important yet. because if the brightness continues its current trend, 3i Atlas will cross a visibility threshold where even small ground-based telescopes will detect the unusual structure in its coma, which means the world is about to see what only a few space agencies know right now. And whatever NASA just confirmed, whatever they now understand about the true nature of 3i Atlas is going to become impossible to hide. The more scientists compare the newest James Webb measurements with earlier data from Hubble, the more they realize this object has never followed a natural evolutionary pattern. A comet's coma doesn't stay stable while the nucleus darkens. A rocky asteroid doesn't suddenly form a halo of charged particles. And nothing drifting through the inner solar system should maintain a magnetic envelope that behaves like a controlled field. Yet that's exactly what shows up when researchers line up the spectrograph data from Webb, the archived readings from Arecibo, and the plasma density estimates pulled from ESA's solar orbiter. And behind the scenes, several analysts from the Harvard Smithsonian Center for Astrophysics said the quiet part out loud. Whatever 3i Atlas is doing, it isn't reacting to sunlight alone. They pointed to one specific detail. Webb recorded a repeating glow at the edges of the coma, almost like a pulse. Not random, not chaotic, a rhythm, slow, steady, and identical across every exposure, even when the telescope switched filters. That's the kind of repetition that normally comes from machines, not melting ice. At NASA's Jet Propulsion Laboratory, a small internal group working under JPL's Planetary Defense Office tried to explain this pulse as thermal cycling, but the numbers refused to cooperate. The infrared signature didn't match heat expansion or outgassing. Instead, it matched something closer to an energy modulation, like a booster ramping up and down at fixed intervals. And when a researcher from Stanford mentioned Ronald Bracewell's old concept of a self-guided probe, something that could survey star systems without needing to report home, the room reportedly went quiet. Vera Rubin Observatory made things even harder to ignore. Their deep sky tracking cameras spotted subtle course adjustments along 3i Atlas path, tiny but unmistakable, exactly the kind of fine-tuning a craft would make if it wanted to maintain a specific distance from gravitational wells. Natural bodies drift. They tumble. They wobble. They certainly don't make micro-corrections timed with solar wind spikes. And that's what really unsettled scientists. 3i Atlas doesn't seem to be avoiding gravity. It seems to be using it the way Voyager 1 used planetary slingshots decades ago to conserve fuel and extend its mission. But this object has no visible engine, no venting trails, no plasma arcs. Yet it maneuvers with the same subtle precision as a probe built with knowledge far beyond our own. The Keck Observatory in Hawaii added another strange detail. Their adaptive optic system caught glimpses of a structure inside the coma, something rigid, something with edges too straight to be natural. But each time Keck tried to refine the image, the object shifted orientation, as if turning its brightest surface away from Earth. And that's when suspicion grew that 3i Atlas is not just reacting to the sun, it may also be reacting to us. That idea reached NASA's public-facing department only after leaked messages from the web processing team revealed that the glow pattern around the object changed whenever Earth-based radio telescopes pinged its region of space. Arecibo may be gone, but several smaller arrays, used the same frequency ranges for calibration. And every time they did, the coma flickered, not randomly, not faintly, but sharply, almost acknowledging the signal. This is the moment when multiple agencies realize the same uncomfortable possibility. Whatever 3i Atlas is, it may already be aware of Earth's presence. Not in a paranoid sense, not in a Hollywood invasion sense, just observant, in the same way we would observe something that has suddenly begun watching us back. Scientists aren't using the word technology, at least not publicly. But behind closed doors, the working description is getting dangerously close to it. A structured core, a magnetic envelope, non-gravitational motion, a controlled coma, course corrections, responding to radio waves, and a path that continues to curve closer to Earth's orbital neighborhood with each passing week. Nothing about this is fitting into the old categories anymore, and that's exactly why the silence from NASA has become the loudest signal of all. And now, as more data feeds in from NASA's Deep Space Network, the situation around 3i Atlas is shifting faster than anyone expected. One of the analysts at the Jet Propulsion Laboratory said something that caught a lot of attention. Objects don't change their signal profile without a physical reason. And that's the problem none of the standard physical reasons apply here. The brightness spike is too stable. The thermal readings are too organized. And the radial drift, measured using the Hubble spectrograph records, is almost too smooth, as if it's happening under guidance. At the European Southern Observatory in Chile, astronomers using the VLT array reported that the coma surrounding 3i Atlas isn't behaving like gas just being pushed by sunlight. Instead of scattering outward in random directions, parts of it seem to tighten and then expand in repeating patterns. One researcher compared it to breathing, though she admitted she wished she hadn't used that word on camera. But when you see the plotted curves from ESO's instruments, that's exactly what it looks like, waves forming and collapsing with rhythm. Meanwhile, over at the Vera Rubin Observatory, long exposure tracking revealed a second anomaly, faint reflections, almost like small reflective bodies, moving around the object in highly consistent arcs. Those arcs don't match any known natural debris behavior, and they certainly don't match sublimation jets. They're too clean, too circular. One of the Harvard-Smithsonian astrophysicists studying those tracks said it best: debris doesn't orbit debris. The more these institutions compare notes, the more each of them ends up describing a pattern that feels intentional, not because they want to. Scientists don't like making leaps, but all the numbers push them there. Even the Arecibo Legacy radar archives, used as a comparison reference, show nothing in recorded history with this combination of mass, motion, coma behavior, and spectral emissions. 3i Atlas stands alone. But what raised eyebrows the most came from Keck Observatory in Hawaii. They ran a polarization scan on the reflected sunlight coming off the object's surface, something that normally helps identify dust composition. Instead, they got a gradient that didn't match rock, ice, carbon compounds, or metallic blends. One Keck specialist said the signature looked layered, as if the surface is made of multiple materials fused in a way nature doesn't usually attempt on its own. Another unexpected twist came from Voyager 1 telemetry comparisons. Engineers used old deep space signal processing techniques to clean up faint electromagnetic fluctuations around 3i Atlas, and what they found shook the room. The pulses repeat in a ratio that matches harmonic structures. Bracewell referenced decades ago in his theoretical models for detecting artificial signals. No one is saying it's artificial, but no one is ruling it out anymore either. Every new update adds pressure to the question everyone's avoiding. If 3I Atlas isn't a normal interstellar comet, then what is it? Even NASA's tone has changed. Reporters noticed it immediately. The language is careful, the adjectives are precise, the pauses during briefings are longer, and the silence about certain details, especially the growing structural symmetry seen in the latest James Webb images, is louder than any statement they could make. Scientists aren't shocked because something is happening. They're shocked because everything they thought should happen isn't. And as more observatories synchronize their observations, from Rubin's sky survey grid to Webb's infrared imaging, the data is starting to align in a way no one was prepared for. The structure isn't random. The emissions aren't random. The motion isn't random. Whatever 3I Atlas is, it's behaving like something that knows exactly what it's doing. And according to the newest trajectory fit from JPL, it's still coming closer. 3I Atlas reaches the moment that scientists at NASA, ESA, and the Harvard Smithsonian Center for Astrophysics were quietly preparing for, but hoping would never actually happen. The newest data package from the James Webb Space Telescope arrives at the Deep Space Network Station in Canberra, and within minutes, researchers noticed something none of them were ready to process. The object's thermal signature isn't just fluctuating, it's stabilizing, almost like it's regulating itself. Objects this size don't do that. Comets don't do that. Even active asteroids don't do that. But 3I Atlas is now showing what one spectroscopist described as a continuous and intentional energy plateau. Minutes later, the Vera Rubin Observatory confirms something even harder to explain. The coma surrounding 3I Atlas is no longer expanding because of sublimation. It's pulsing outward in exact intervals, clean, repeating intervals measured down to microseconds. Arecibo legacy researchers compare it to the timing patterns once proposed in the Bracewell probe concept, the idea that an advanced civilization might send autonomous machines into deep space to observe young worlds. And then it gets stranger. A high-resolution reprocessing from Webb's near-spec instrument reveals 3 repeating streaks of infrared reflectivity underneath the outer dust blanket. They're symmetrical. They're aligned. They're not random geological fractures. A team at JPL tries to fit these into natural models' impact scars, deep mineral seams, fractured frozen volatiles. Nothing fits. The only explanation left is the one nobody wants to say first. The object's interior structure is organized. The room at NASA's Goddard Center goes completely silent when the Voyager 1 comparison data arrives. The magnetic field disturbances around 3I Atlas match nothing in existing catalogues, but their curve almost mirrors the electromagnetic echo Voyager picked up near the heliopause years ago, a signal still debated to this day. Now the pattern is showing up again, this time on an object heading straight toward the inner solar system. This is the moment where all the open questions collapse into one heavy conclusion. 3I Atlas is not behaving like a comet, not behaving like an asteroid, and not behaving like any natural interstellar body humanity has ever documented. And now it's close enough that even ground-based telescopes like Keck in Hawaii can track structural features that shouldn't exist. Something inside this object is active. Something inside it is maintaining heat, rhythm, and symmetry. And whatever its origin is, the agencies studying it can no longer hide behind anomalous readings or unexpected outgassing. Not when the patterns are this clean. Not when the signals repeat. Not when Webb and Rubin and JPL and Arecibo datasets all converge on one conclusion. Scientists aren't saying it publicly, but behind the secured doors, the phrase being repeated is simple. We finally caught the attention of something older than us. And whatever 3i Atlas really is, whatever its purpose might be, whatever message or mechanism is hidden beneath its glowing coma, it's getting closer fast. Humanity is no longer just studying it. We're now part of whatever comes next. Thank you for watching. If you want to stay ahead of every update on 3i Atlas and the strange signals NASA still hasn't explained, tap subscribe and watch the next video appearing on your screen. Right now, it connects everything we just uncovered.